All right, I'd like to take you through how we fill in the entire unit circle. Let's first start with the first quadrant that we have already talked about how to generate using special right triangles. Before I get started, I want to give credit where credit is due. If you would like to get extra copies of this, embeddedmath.com provides these for free. Great resource. I love the way things are set up. And so I highly recommend that you check out their website and you can print from there. All right. In our previous lesson, we learned how to generate the 30-degree angle, the 45, and the 60. And we talked about how these related to our special right triangles and the proportions that we had learned. For the 30, 60, 90, we have the 1, 2, square root of 3. And for the 45, 45, 90, we have 1, 1, square root of 2. So if you remember, I showed you that in this case, the 30, if I was to connect back to the x-axis and draw that special right triangle, the short side, which is the y distance, was the 1/2, because to generate that short side, we looked at our hypotenuse, which is a 1, and we divided by 2. And then to get from the short side to the side across from the 60, we multiplied by the square root of 3, and that gave us square root of 3 over 2. Now, the 45, 45, we knew that both sides of the 45, 45 had the same measurement. And so if our hypotenuse was 1 and we divided by the square root of 2, we ended up with 1 over the square root of 2, which could not be because we can't have that radical in the denominator. So we rationalized and we got square root of 2 over 2 for both sides. And then I showed you on the 60-degree, we have these same two answers, but they swap sides, because now if I was to connect this back to the x-axis, the short side is on the x, which makes that the 1/2, and the longer side, the square root of 3 over 2, becomes your y. Now here's the good news. Every single one of these other quadrants are going to have these same three answers. And so all you have to do is keep in mind which one represents the 30, which one represents the 45, and which one represents the 60. Think of them as reference angles. The ones that are closest to the x-axis, these 4 right here, all represent the 30-degree reference angle. And so all of these are going to have the same answers. So I can just copy that all the way around. The 45s are the ones in the middle all the way, and they all are square root of 2 over 2. And then the last one would be your 60-degree reference angles, these last 4, and they will all be 1/2 and then square root of 3 over 2. Now, I'm not done yet, because you remember yesterday we talked about how to determine the signs of each of our quadrants, and we're actually going to go ahead and write these things out here also. The way that we can determine what is positive in each quadrant is we used the phrase, all students take classes. And so that tells me that everything is positive here. So sine, cosine, tangent, and then all of their inverses also, which would be cosecant and secant and cotangent. All right, so everything's positive here. In this region, quadrant 2, only sine and its inverse, cosecant, are positive, which means everything else falls to the second line. So cosine, tangent, secant, and cotangent are all on the second line. They're all negative. And then down here, only tangent and cotangent are positive, which means everything else is negative. Sine, cosine, cosecant, and secant. And then in this fourth quadrant, cosine and its inverse, secant, are your positives, and then everything else is negative. All right, that is going to affect these answers that I've written. So in this first quadrant, everything's positive. It can stay just like it is. In the second quadrant, only the signs are positive. And so if you remember, sign represents the y values, which means all of my x values are negative. So I have to put a negative sign on all of those. You'll notice down here, both sine and cosine are in the negative. And so I need to put negative signs on everything. And in this fourth quadrant, cosine is positive, but sine is negative. And sine is your y, so all of my y values are negative. All right, so now we've taken care of our signs. Let's go back and let's go ahead and fill in all of our degrees. Now, we talked about yesterday that we know this is 0. One of the ways that you can go around and fill in your degrees pretty easy is by counting your way around the unit circle. It's going to do a very specific pattern. It's going to go 30, 15, 15, 30, 30, 15, 15, 30. And so if you consistently add in that method, you can go around and fill in pretty quickly. So you can see I've added 30, add 15, add 15. When I add 30, I get 90. Add 30, I get 120. Then I do 15. 15 again, and then 30. 30, 15, 15, 30, 30, 15, 15, and 30. All right, we filled that in pretty fast. Now we can go back and we can do all of our radians. And you have the option of, you could actually do a conversion. You know, you could divide each of these by 180, and that will tell you what your radian. We talked yesterday that this is pi over 6, because if we do 30 into 180, we get 1/6. This is pi over 4, and this is pi over 3. We also went ahead and filled in those major parts. Right here was pi over 2. This was pi. This was 3 pi over 2. And this was 2 pi. And so you can see we only have a couple left that we need to fill in. There's a couple ways you can do this. You could start off, I can see that my circle is divided into fourths. And I could count my way in fourths. This would be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. So that filled in several. And then I could go back and I could count in 6. That also works. 1/6, 2/6, 3/6, 4/6 reduces to 2 pi over 3. 5/6, 6/6, 7/6, 8/6 reduces to 4 pi over 3. 9/6, 10/6 is 5 pi over 3. And 11 pi over 6, and then 12 pi over 6. So now we filled in all of our radians. And then the last final thing I need to fill in are the coordinates of these quadrantal angles here. We've got, remember, it's a unit circle, so we're going 1 in each direction on our XY axis. So this would be 1, 0, 0, 1, -1, 0, and 0, -1. And that is your entire unit circle.